All right. While Nathan sets up, this takes a few minutes to set up, I'm going to do a quick demonstration. In Steve's presentation, there was an excess of fuel, and it had to travel up and down the tube to get to the available oxygen. So you saw this flame going up and down. This is a model, and we'll call this a model of a car engine for lack of a better example. This is the cylinder, and I have a piston that I'm going to put in one end. I need to run over here. Grab this. Oh, I just like it. And we can calculate, and your automobile engine does, how much oxygen is in here. And as a student, you can balance the chemical reaction between fuel. The fuel we're using in this case is butane and oxygen. So what we've got now is a stoichiometric mixture of fuel and oxygen. Now, in this reaction, an automobile constantly monitors how much fuel it is injecting, and in that process ends up always ensuring that you have the best fuel economy, but that you also don't have an excess of fuel which wastes money. It also throws hydrocarbons into the atmosphere, or an excess of oxygen, in which case you could have the reaction with nitrogen, get nitrogen oxides and the like, which are bad for the environment. They cause the ground level ozone and the brown haze you see over some cities. If this is an automobile engine, the one thing I can't do is I can't compress it by about a factor of 10 to 1. So it's a limitation in my model. So what you're going to see in here is about 1/10 the impulse. The same amount of energy, just about 10 times slower, that happens in an automobile engine.